Today's video has to do with mixtures. Mixtures, we've talked about these a little bit before in class, but I want to talk about them a little bit more in detail now. What is a mixture? What are different types of mixtures? How can mixtures be separated? And then we'll finish up today with density, and we'll be working with density a little bit in class next time. So, we did talk before, as I said, a little bit about mixtures and something called pure substances. Now, just a little refresher. A pure substance is going to be a material that has the same composition throughout, so it looks the same, and it cannot be separated except by using a chemical reaction. Water would be an example of this. Water, you can put it through a filter, but it's still water. And all water is going to have 2 hydrogens and 1 oxygen. It doesn't matter where the water came from, as long as it's pure water. Whether it came from a lake or a mountain spring or was deep inside the ground, all water is the same water. All gold has the same melting point. These properties are going to be the same for pure substances. So a pure substance can either be an element, which is one of the things that we find on the periodic table, or it can be a compound, which is a mixture of elements linked together by a chemical bond. More about those later this year. A mixture, on the other hand, is going to be a combination of 2 or more different pure substances. Salt water, for example, or let's see, the human body is a very good example of a mixture. There are many, many thousands and millions of compounds all mixed together to make the human body. So a mixture can be homogeneous, and homogeneous means it has uniform composition. You cannot tell that there's different things mixed in together just by looking, because it all looks the same. These are also known as solutions. Solutions are homogeneous mixtures. What would be another good homogeneous mixture? Windex. Windex, for example, that blue spray that you use to clean the house. It's more than just water in there, but when you look at it, it all looks the same. Contrast this with heterogeneous mixtures. Heterogeneous mixtures. These have a non-uniform composition. You can see that there's a bunch of stuff mixed in there. Easily coming to mind for me would be dirt from outside. You pick up a handful of dirt, you can see all sorts of things in there. Some decomposing leaves, maybe some bugs, a little bit of sticks, some pieces of grass, some little tiny rocks. That's a heterogeneous mixture. Mixtures can be separated without using chemical means. That's what makes them different than pure substances. There's several different types of separation techniques worth considering. One of the easiest to understand is filtration. Filtration involves nothing more than using a filter. It can be something as simple as a piece of paper. You can filter, for example, muddy water, and the mud will stay behind on the paper and the water will flow through probably a little bit cleaner. I still probably wouldn't drink muddy water that I ran through just a sheet of paper. I would want to do some more cleaning to it. Distillation is another one. Distillation involves boiling different compounds out of the mixture. Now, as you'll remember, different materials boil at different points. If you want to learn about a really interesting example of this, you can look up something called fractional distillation. Fractional distillation involves taking crude oil that's pumped out of the ground and raising its temperature to different amounts to boil off different products that you want. Gasoline boils at a certain temperature, kerosene boils at a certain temperature. All these different things that are in the mixture will boil off. Then you collect that vapor, cool it down, turn it back into the liquid. That's distillation. It's also used in producing many beverages. Decanting. Decanting's nice and simple. You have a container that has some gross stuff at the bottom, clear liquid at the top. You pour off the liquid without disturbing the gross stuff at the bottom. Centrifuge. A centrifuge is a machine that takes a container, let's say a test tube or something similar, with a lid on it, maybe a small beaker, and it's going to spin it around very, 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 very quickly. Spin, 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 spin. The things that are heavier are going to sink to the bottom of the tube. The things that are lighter are going to stay near the top. That's a centrifuge. And chromatography. Chromatography is probably one of the more complicated types of separation techniques, but due to molecular attractions between different things, some things, for example, are attracted well to water, and some things aren't attracted well to water or other liquids. So there is a technique that you can do called chromatography where you separate things based on their attraction to certain liquids or solids. Over on the right hand side of the screen, this is the use of chromatography to separate out different plant pigments. So you put a drop of plant pigment right here, the colors in a plant, it looks like a very green thing, and you dip this piece of paper here into what's called an organic solvent. It's a liquid, and the different pigments that make up this spot, there were different colors in there. Some of them are attracted very, very strongly to that liquid, like the carotene pigment, so that's going to move fastest. And then the xanthophyll is attracted a little bit less, that's going to move slower. Chlorophyll's attracted not very much at all, that's going to move even slower than that. So that's another type of separation. But all these separation methods, again, these are not chemical reactions. These are used to separate mixtures. It doesn't change what we had, it just splits the individual substances out of it. Okay, then I've got a bunch of different examples of substances, both elements and compounds and mixtures, both homogeneous and heterogeneous. Take a look at this list, try to figure out which things are substances and which things are mixtures. We're going to do a little activity with those next time. So just start thinking about it right now, and then you'll be good to go for next time. One last thing to talk about today is density. Now, density is simply a ratio. So if you'll think back to math class, ratio means that we're going to be dividing of the mass of an object to its volume. We did a little bit with this already when we were doing properties. In equation form, that's D, density, equals m over v. Density equals mass divided by volume. One interesting thing about density is that things that are less dense will float if you put it in something that is more dense. Over here on the right, you've got liquids separated in terms of density. The things that are most dense have sunk to the bottom. The things that are less dense have floated to the top. Or, for example, a helium balloon is going to float because helium is less dense than air. The most common units used for density are going to be grams per cubic centimeter or grams per milliliter. Those cubic centimeter is pretty much the same thing as a milliliter, but cubic centimeters are typically used for solids, milliliters are used for liquids. Density does change with temperature. So typically densities are recorded at room temperature so that you can look them up. Now, why would that be? Take just a second to think. Why might density change with temperature? If you remember KMT, kinetic molecular theory, you'll recall that temperature, with higher temperature, the particles are moving around more. The volume is actually changing in objects with temperature. As a room gets warmer, the objects in the room get warmer, and they actually increase their size. Some of them a lot, some of them a little bit, but that size is going to change, so that will change the volume, but the mass would stay the same, so the density would change. Let's try a problem. A sample of aluminum metal has a mass of 8.4 grams. The volume of the sample is 3.1 cubic centimeters. Calculate the density of aluminum. Pause the video and take just a minute to do that real quick. And we're back. You should have gotten 2.7 grams per cubic centimeter. If you didn't, come see me. We need to work on this. Density is fairly important. One last thing, is density an intensive property or an extensive property? You'll recall that intensive means it doesn't matter how much of it we have. Extensive means it does. And it is an intensive property. If you have a gold bar and you cut that gold bar in half, sure, you have less mass, but you also have less volume. The density stays the same. Thanks for listening. Don't forget to do the whisk. I'll see you later.